Hello, I'm Ellie. I've been playing a little bit with Autogen in Azure Machine Learning using AI Studio services, and I deliberately wanted to try and see if I can create for myself a setup that would be useful for anybody who's doing scenario modeling. As I was learning how to work with Autogen and figuring this out, I got more and more and more and more excited. This is amazing. This is really, really wonderful. And the potential here is unbelievable. So let's get to it. So let's imagine a scenario modeler, somebody who is a subject matter expert, and my regular uh, scenario for this is the bird population, where we've got a model that takes into account births and deaths and how much food and so forth, and predicts the population forward. So this scenario modelers gets a particular task to evaluate the potential of impact of some construction on a particular type of bird population in a particular area. This subject matter expert knows the birds very well, but they go and do a little bit of research to have some evidence behind whatever they decide to design the scenario. Then they decide these are the scenario parameters and justify them. They go and program. Nowadays, everybody programs just in Python, but program in some language a um, some scenario, some engine that represents the behavior of the population under different conditions. Because it's programming, you have to debug it. When you run the model, you get the results, you assess the validity of the results. Yes, no, maybe I need to go back, there's a bug, or maybe I need to change my assumptions. Um, then I need to report this, so I write some code that reports it, or use some dashboard to do the reporting. Then I have to debug the whole thing and ensure that I'm getting what I expect, and then I spend some time communicating. This is very time consuming. Not only that, this is kind of repeatable, right? Because each time you get a question, you go through the whole process again. But each time it's a different bird species with different specific questions, with a different construction, with a different setup that is worrying you. So you constantly need to change things. So what we usually do, we build ourselves some tools, some functions, some utilities, and each time we cobble up those utilities and combine them and add a little bit of more code to bring it all together. That's what we do. So this is the art of anticipating the unanticipated. So this is something that is a little bit hard to automate with regular automation tools, because there's a lot of change that happens that is chaotic enough not to allow us to build for all different possibilities. So this is where the agentic AI comes to its own. So this is the agents that I've decided to use for my demonstration. First of all, I've got an ecological expert that can go and do the research. Then I've got a scenario architect that interacts with the ecological expert and translates then the knowledge into a set of parameters that define the scenario. I've got a simulator that in this case is I wanted to learn how to use existing functions. So the subject matter expert has built a Python function that describes the population. There's no need for the agents to constantly recreate the construction of this model. This is how the subject matter expert um, communicates the expertise for here's a function that I've built that I always use. This is my utility. Don't invent the wheel and don't waste the tokens on this, please. So, and once I've got the simulation, then I need to build a report. And because the reporter builds Python code, then I've got an agent that evaluates the code, checks if it's working correctly as expected, and suggests improvements. And I need some function, some agent that will coordinate everything. And this agent also allows for interaction with the subject matter expert. So when the whole team starts working, they can have points where they say, okay, they're subject matter expert. Do you agree with this? Would you like us to change direction and so forth? So it's not that we are building this is totally building out and replacing the subject matter expert. It's tools to make the subject matter expert work much more efficient. So here's my instruction that I've given my research coordinator, and it's deliberately vague. It's not, oh, I want you to test a scenario with these parameters. It's, look, I'm talking about puffins in Scotland. They're healthy at the moment. Give me a scenario that mainly looks at a significant reduction in food sources, and give it over 25 years. Go figure it out. Now, you can figure it out on your own, just automatically, and this is what's going to happen in this demo. But in real life, what I would expect is there's a lot of interaction with the subject matter expert, and this is his team that works for him or her. So, first step, and I'll show you in how it looks afterwards in my code. But what happened when I gave the instructions, I set up the agents. What happened was that the first step that in one of the discussions that I'm describing here is that the scenario architect over here immediately goes and asks the ecological expert to give some information to inform the parameters, and the scenario architect specifies exactly where some assistance is required. So here's a very detailed response from the ecological expert suggesting, by the way, I did a Google search. It believes there's a 400,000. It's in the ballpark. In real life, you might want to ask for the ecological expert to focus on a set of papers, maybe to do a RAG, so it's papers that belong to the organization, and then give quotes from those papers and pointers to them. But what I like here is there's an explanation of the reasoning behind the suggestion for the different parameters. And I saw here something that was really interesting. It's probably in the next page, maybe. Puffins typically have low reproductive rate with 1 chick per year. This should be factored into the model. Here you go. Breeding success rate has to be relatively low. That's interesting. So the suggestion is a breeding success rate of half to 0.7 chicks per pair per year. I don't know if this makes sense or not. But I'm just, my mind is blown. So I'll just summarize because the conversation between the different agents is quite long, but you get a scenario suggested that is accepted by by the expert. So then it's handed over to the simulator. The simulator, I've given it the instruction just to give out one vector of the death rates. So here's actually the output that is provided, just calling the function. And then the reporter generates some Python code, and the code reviewer has a look at it and says, generally it's okay, but I've got one suggestion. I'll show it to you in a second, later in the code itself. So you believe me, it's in the code, that I haven't invented this. And then a graph is generated and the conversation is ended. And it took me not that long to figure out how to get Autogen to work. A little bit of a harder work to ensure that it works within Azure Machine Learning, but I figured it out in the end. And it's using an API service from the AI Studio in the same environment that I am in. So let me show you how it looks. So First of all, let's talk about the output. So this is just to orient you. This is obviously VS Code sitting within my Azure Machine Learning environment, and I'm taking information from the AI Studio. And I'm not going to dwell too long about how to configure everything to work and so forth. Just a few comments that I've learned on the way. But first of all, let's look at how the discussion looks. So here's the code itself. It's quite legible and readable. I'll walk through it in a second. But more important, this is how the conversation in the raw looks like. So the instruction, then the first speaker says is the scenario architect. This is the chat that I copied over. Then you've got the bird model simulator, takes these parameters, generates this output. The reporter takes the same output and builds Python code, sends it to the code reviewer to check whether it's fine or not. The code reviewer says, generally, this is okay. The code structure is clear, but there's a recommendation. Where's the recommendation? So there's a suggestion here, please would you revise the code with a little bit of error handling. So then, when the code is generated, there's suddenly a try appears here. Not sure if you really need a try just for writing the file, but fine, okay. And then that conversation is ended, and the output goes over here into a folder. So let's look at the code itself. I'm not going to go blow by blow, but as you can see, I'm using Autogen. The config points me at the service from the AI Studio. One thing that I learned to get it to work within Azure Machine Learning is cache seed none, not 42, not whatever other demos show. For some reason, this needs to be none. And the other thing that I needed to modify from the different tutorials that I've seen was that at the end of the code, when I come to do the key call, which is please initiate a chat with this, I need to wrap it up with a specific pointer to a location in, and you can see here, the local folder in the VM and not the Azure Machine Learning blob storage. This is took me some time to figure this out. Apart from that, this is generally looking similar to many different tutorials that I've done. So I'll walk maybe backwards a little bit for a second. Here's the group chat manager set up, and the group chat manager has the following agents: the user proxy, the architect, the build expert, the simulator, the reporter, and the reviewer that I told you about. Now, what you see from the top, if I now go from the top, is that I define my bird simulation function in a particular way, and mainly what it does, it brings in a package called BearPy, which I discussed in a different video that I've done about parallelization within Azure Machine Learning, and just calls it with the particular parameters. Here's a definition of the user proxy. So that the user proxy really has the role of the research coordinator, and I'm giving it quite detailed instructions. And this costs definitely tokens. I had to up the token limit a few times. And then I've got the architect, and I give it these instructions. I pointed at where it can learn from the paper behind this particular Python package, where it can learn about it and what are the parameters that are expected. And I'm giving it all sorts of instructions like ask the ecological experts for known values, da, 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 once you have accepted it. So this is how the subject matter expert can put into the definition of the agent their knowledge. Avoid this, do this, think about this. Remember that in Scotland things are different than in Wales for some reason or another. Um, here's and then this is the bird model simulator. This is a much shorter description because I'm telling it only use the functions I'm giving you. Don't really behave like a crazy LLM. And then it says here's the function, right? And please also execute it. One interesting thing that happened, I couldn't get it to work. I couldn't get it to work. And a side comment that a colleague of mine made to me the other day, he said, "Look, I'm using OpenAI 4.0." And I said, "Yeah, but the whole point of these agents is to use smaller agents, smaller LLMs that are very, very focused." And then I realized that this particular agent needs to be of a stronger capability to understand the instructions. So maybe this is something that will be resolved with later versions of things like Autogen and so forth, because I am expecting to use definitely lighter and smaller agents and plonk them into containers and so forth, which I haven't done here. So then you can have it running in Kubernetes. Here's the reporter. I'm asking it to generate code, and this is the code reviewer. And generally, I'm telling it, you check the code, right? And the bird expert is you are an ecological bird expert. You provide expert knowledge. You focus on birds. And by the way, for some annoying reason, if you don't put these instructions, the agents will be extremely polite, saying thank you and please and you're welcome, and wasting a lot of tokens on things that I don't really want to pay. Um, so I am really, really, really excited about this. And then here's the different output that it gives. It gives me the code that is generated to do the plot. Here's the plot. Here you go. So in this case, it's showing the infected individuals, and because there's food shortage, there's also diseases that are associated with this. The population becoming hungrier and so forth. So the affected population is growing. So I think this is very, 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 very exciting. Um, and I see a lot of potential for these agentic AI paradigms. Uh, I do need to give my mind to thinking about how does one put some governance around this? How does one provide this as a enterprise-wide capability where people share definitions of agents and so forth? You've got, to an extent, you've got that capability built in the Azure AI Studio. There's a concept here in preview that's called assistance, and you can see that you define a prompt, you give the tools. So the tools could be use this function, use this API, you give it some parameters to work with, so you can build some communication between the assistants. So I think this is a really exciting emerging technology that, yes, there's a lot still to mature within it and a lot of things to figure how to govern it, how to use it safely, how to ensure that you're getting the results that you want, how to interact, to build it in such a way that subject matter experts will gain from this. But I'm so excited. Thank you very much for listening.